Hi there, and welcome to some random bits. Today I'm going to have a look at PICO-8, which is this cool little fantasy console. It basically mimics an old school microcomputer from the 80s, and it's a really neat little program. Firstly, it gives you this little shell here, which you can run all sorts of commands to load files and change directories and do that kind of stuff. You're also able to execute commands from the command line or from the shell, the classic microcomputer styles. It also comes with a little code editor, so you can create your own programs and edit them, and then when you exit back out you can run those. Besides the code editor, it also comes with a Sprite Editor. So for instance, if I create a little ball-like sprite here, or rather in this slot over here, I think. And I'll give it a little bit of shading, look like a little bit of a light source on it, and maybe I will create a little bit of a ground tile sprite, fill that in there, and give it a little bit of texture, and maybe a little bit of color in the grass here. And then you're able to use these sprites anywhere within your game that you write. It also comes with a map editor that allows you to draw maps using those sprites, and you can pan and scroll those around within your game world. It also comes with a sound effects editor, so if I do that, we can get some interesting sounds, or some kind of noise, or that kind of stuff, or just some explosionary type stuff. And you can mix and match all those kinds of things. If I did that, and then maybe take a bit of this one, add it in there. And then it also comes with a kind of a tracker, so you can write your own little bits of music. So and that style of stuff. Ooh. Which is all pretty cool. All of this means that you can land up writing programs like this one. So if I go to the demos that ship with the application, and we can load this one, for instance, and run it. I get this cute little classic platformy type game, which I'm not very good at. So yes, that's a pretty impressive what you can actually do with such a constrained system. So what we're going to do today is we're going to write a little game. For years and years I've been fixated on things like the classic little Tron Light Cycles game I think I'm going to work on. But before I do that, I'll talk a bit more about how it actually works. So the programming language is actually Lua inside, and what we can do is we can write a very simple little program here, which would just let us move the ball around on a ball shape on the screen. There's two kind of, or three kind of key functions within the system, within the engine. The first one is the update function, and this gets called about 30 frames per second, so every update of the game. So in here we can kind of update the kind of game state, and in this particular example, which comes out of the instructions, what we're going to do is we're going to look to see if a particular button has been pressed, and then with the up, down, left, right buttons, and adjust the X and Y values that we have. So this will be x plus 1. So that covers left and right. And these map to the cursor keys. It's kind of got like a gamepad mapping for a lot of the keys. So you get a bunch of those. And for the Y minus 1. And lastly, the button for adjusting the up and down. Now the game screen itself is about 128 pixels by 128 pixels, so it's kind of really tiny and retro, and all those sprites were 8 pixels by 8 pixels. And you'll see down over here in the bottom corner you've got kind of a limited amount of code size as well, so the whole thing's designed to be constrained. In fact, when you save your program, you can save it in a text format, or you can actually save it as a PNG format, like an image with a screenshot of your game and actually all the game code embedded in the PNG, which you can then upload to a website and have run over there. So that actually takes care of our update function. And the next function we want to do is our draw function. So in here we're going to fill up the screen with a color. So basically blank out the entire screen. And this is going to be called every frame. So the full 128 pixels we're going to clear out there. And then lastly, we are going to draw a ball by using the circle fill command, and we're going to draw that the X and Y colors that we currently have with the size, location with the size and color. And we're going to end that off there. So hopefully, if I haven't made any mistakes, we can exit back out there and type run. And we have a ball on screen, and I can move it around with the cursor keys. So all nice and straightforward. Let's reboot, and we can start with my light circles game. So in this game here, it's very simple, 2-player game. What basically happens is, in the classic top-down, you're drawing little lines, and you've got to avoid crashing into your line or your player's line, and whoever crashes first loses. So what we're going to do here is just do the first pass of getting one player up on the screen. And this is quite an easy game generally to write, because all you need to be able to do is read the pixels to see if you've crashed into something, or put a pixel to update a player's position. So it's always been a very simple game that I like to build on lots of little platforms to test things out. So firstly, we're going to set up a variable for the player 1, and we're going to control their location, and this is their starting XY location, and we're also going to set up a direction, which is the direction they're currently facing, and we will use 1 for up. And then in our update function, we are going to basically update their location based on the direction they're facing. So if we can say p1.dir is equal to 1, then we want to say p1.y equals p1.y minus 1 end. Okay, we'll leave that there for the moment. And then in the draw function, we will use the pset command to actually draw a pixel on the screen. So p1, py, and we're going to use a nice blue color. So there's a preset palette of 16 colors, and color number 12 is blue. And send that, and exit that, and hopefully we can run that, or maybe not. Attempt to index a global null value. Ooh, okay. Yes, I didn't initialize p1. So this is using a Lua table. So that's why we need to set that up like that. Hopefully I got that right. And now we have a blue line drawing up the screen. You can see, of course, we didn't clear the screen or initialize anything like that. So let's do that. One of the other functions, the other built-in function that runs is the Init function. And this runs when you once at the start of your game. So what we'll do is we'll just stick a clear screen in there, and we could now hopefully run that. If I didn't make any typos. Clear screen function, yes. And there's my clear screen and my line drawing up the screen. Okay. So let's copy this line a little bit to handle each of the 4 directions that we want to go. So if 1 is up, 2 will be to the right. So we want to adjust the X value. And 3 will be down, so we want to add to the Y value. And the 4th one will be left. So we want to take X and -1 from X. Cool. And now we actually need to be able to change the direction, so we will just get the first bit of code in here just to say if button 0, which I believe is left, is pressed, then we want to say p1.dir equals p1.direction. Let's see, if we're going left, we want to -1. And then we want to do a check at the bottom here to make sure that if we flip around, so we say if p1.dir is greater than 4, then p1.dir is equal to 1. And if p1.dir is less than 1, then p1.dir is equal to 4. So that should hopefully wrap us around. Let's give that a try. And if I hit left, oh yes. Now, if I hit left, you just see I'm spinning around in the circle here, because it's actually very sensitive to the button being held down, not a button press, but we can fix that by using the button P function rather than the btn function. We can use the btnp function, which basically looks to see if the button has been pressed in this update. So run that. We can now turn around in circles, but only go left. So let's introduce going right. So we just copy this line over here. And in this case, we want to increment the direction, and we want to check if button, the other button, which would be button 1, I believe, for right. Let's give that a try. So now I can turn right, and I can turn left. Excellent stuff. All right. That's probably it for the moment, so we'll just save up, and in the next video we will add the checks to see if we've crashed into things, and we'll take it from there. Cheers.